Hi, welcome to lesson number 5 on this tutorial series on practical electronics designs. So far, I've been introducing us to various concepts that are very important in this course, but today we'll be building our first circuit on the breadboard, so we'll get our hands to do something today. Now we'll be going to our first circuit. This is the circuit you are going to build on the breadboard. Before we get our hands into building, let's understand the circuit. As basic as it is very important to really understand what is going on here. This is a battery that we want to use to power up this LED. Of course, I've told you that LED is a light emitting diode, and anytime current flows through it, it emits light. And so we want to power this LED. You would have said, wow, why not just connect the LED directly to the battery and let it come on? Why? What is the essence of this resistor that we are putting here? Well, you have to understand that every electronic component has a particular rating. It has both voltage and current rating, and once you exceed the normal or the allowable voltage or current that it requires, you will get that component damage. If you pass so much current, more than this can handle, it's going to burn off. And so you always want to protect your LED or protect your components from damage, and that's the reason for this resistor. This resistor here serves as a current limiter. I've said it before that resistors are used to oppose the flow of current. So what this resistor does primarily is to oppose the flow of current, hereby reducing the electric charges that flows out of the resistor, because this battery has the potential of allowing so much current into this LED, but the resistor limits the current and gives the LED the exact value of current you need. Then how do we now get the right value of resistor to use? And I'll be explaining that in my next slide. Before I talk about that, this is a chart that guides us. Anytime you want to work in any component, LED, diodes, resistor, whatever, it's good to always check the data sheet. There's something we call data sheet. Data sheet serves as a manual that guides us, tells us the ratings, tells us how to use them, how they will function in their best condition and all. I took this from I took this from the internet, and it has several informations that will guide us in understanding the best choice of resistors. I'm not really interested in this first and second column, the semiconductor material or the wavelength. No, I'm interested in the voltage and the current and the color of the LED. So this chart is telling us that for an infrared colored LED, to get the brightest color, you have to apply a current of 20 milliamps, 20 milliamperes. So when the forward voltage of the LED is at 20 milliamperes and the voltage is 1.2 volts across it, then you get the brightest color, the maximum brightness. For the red, when you have 1.8 volts at 20 milliamperes, you get the maximum brightness. These values may change from diode or from LED to LED depending on the material used, depending on the manufacturer and some other factors, but this is a good guide to make us understand, okay, at 20 milliamperes we get the maximum brightness, and this must be the voltage we need. Anything more than this will damage our LED. Now, looking at the circuit, how did we come about this value 350? You have to know that we are considering a 9-volt battery, and our LED, we're assuming that the LED we're using requires a forward voltage of 2 volts, so the amber colored LED. Since our V in here is 9 volts and VF is 2 volts, let us check the calculation. From Ohm's law, you can see that V is equal to I times R. I explained this in lesson number 2. You can check it out. Here, the V that we have here is actually this V in minus this VF. And our V in is 9 volts. Our VF is 2 volts, considering the amber colored LED. So if V is equal to I times R, then R is equal to V divided by I. That's just normal algebra. So R becomes V divided by I. V is V in minus VF divided by I. And recall that at maximum brightness, we'll be dealing with 20 milliamperes. That's 0.02 amps. So R is going to be 9 volts minus 2 volts divided by 0.02 amps, and that's why we got our value of R to be 350 ohms. So 350 ohms with 9-volt battery will give us maximum brightness at a current of 20 milliamps. If you reduce this resistor value to say 300, when you reduce the resistance, you allow more current to flow through. So if you reduce it to say 300, then you expect more than 20 milliamps of current to flow through this circuit, and you damage this your LED. But if you increase it, well, it's even better to increase, because once you increase this to say 470, lesser amount of current will flow through, not up to 20 milliamps, so you won't get maximum brightness. The LED will be dimmer. But it's usually good to calculate and know the best the maximum fit value for the resistor, so that you don't damage your LED. As we design our circuits, then we need to measure the current, the actual current flowing, because sometimes calculated value may slightly differ from real value when you perform experiment due to some random error, experimental errors and all that. So if you want to calculate your current that is flowing through the circuits, you connect your ammeter, which is the measuring instrument to calculate the amperes, the current flowing through. You connect your ammeter through the circuit. So this is the way to connect it. If you are using a multimeter, you set your multimeter to current reading and you connect it this way. The two probes of your meter will be connected to the resistor and the LED. That way you'll be able to know the current flowing through the circuits into the LED. But if you want to get the voltage across the LED, we measure voltage across, we measure current through. So that's something you have to understand from now. Measure current through the circuit, you measure voltage across the circuit. So when you want to measure the voltage across the LED to be sure of the exact voltage that is consumed, or the voltage drop on the LED, you connect your voltmeter this way. So if you are using a multimeter, you set the voltage, you set the correct range, and you connect it this way. This way you'll be able to read the voltage drop on this LED.